Hi guys, in this video I go over the post-order depth-first search tree traversal algorithm. There are two main traversal algorithms, depth-first search and breadth-first search. In this video I only focus on post-order depth-first search. If you are curious about pre-order or breadth-first search, please check out one of my other videos on that. I put a link in the description below. For post-order depth-first search, let's take this tree as an example. So post-order means we visit a node's children before visiting the node itself. Starting at the root node, that means we go all the way down to the first leaf node, which is 76. We visit 76, then we back up to 2. Now that we have not visited all the children yet, so we cannot visit 2 yet. So we go to 39. Can't visit 39 because we still have to visit the children first. So 11. It's a leaf node. That means we already visited all the children that are not there. So we output now 11. So the output at this point is 76 and 11. We back up. Now that we backed up, we have visited all the child nodes of 39. So we output and visit 39. We back up to 2. Now we have visited all the children of 2. So we can visit 2. We back up to 7. We have not visited all the children of 7. That means we go to 13. It's a leaf node. We output 13. We back up. We go down all the way to 4. Back up. Go to 23. Back up. Go to 18. Back up 38, 45, and then 31. And then we back up and output 7. This is also implemented using a stack. For depth-first search, you always use a stack. We start out with pushing the root node onto the stack. Then we visit the first child, which is 2. From 2, we go to 76. This is a leaf node, so we output it. And then we back up and go to the next child of 2, which is 39. Then from 39, we go to 11, push 11 on the stack. That's a leaf node. We output 11 and visit 11. Then we back up to 39. We pop 39 off the stack, visited. We pop 2 off the stack and visited. And now we go to the next node and push it onto the stack. That would be 13. We pop it immediately off the stack. So we visited 13. Now we push 45 on the stack, then 83, and then 4. This is a leaf node, so we pop it off the stack, then 23, then 18. And as we push them, we pop them off immediately. Then we are at 83, we pop it off the stack, we back up to 45, which is popped off the stack, and then go to 7. We have not completed 7 yet, so we still have to push 31 onto the stack. We immediately pop it off the stack, and finally we can pop 7 off the stack, and the stack is empty. That means the output is complete. If you match this output to the post-order depth-first search in the tree, it should match. So we started at 7, we went down all the way one path to 76. We backed up, go to the next path all the way down to 11. Then as we back up, we output the values 39, 2, 13, then go all the way down again to 4, 23, 18, and then as we back up, we have 83 and 45, so 83 and 45. And then go down to 31 and 7. Let's see how we can implement this. Now this is here implemented using a recursive function call. So I basically use the call stack as a stack instead of using an explicit data structure. So I have a function, depth-first search post order. It expects a pointer to a node. Initially I call this function with the root node. And note that the node here has 2 pointers. It has a child pointer to the very first child, and it has a sibling pointer to a sibling of a node. So for the root node, the sibling pointer points to null, and the child pointer points to 2. So I pass in 7, then I get the child of 7, which is 2. 2 is not null, and then I call the very same function again, passing in now 2. So 2 gets passed in. I get the child of 2, which is 76. 76 is not null. Now I call the same function with 76. So 76 gets passed in. I get the child of 76, which is null. So I don't enter the loop, I skip the loop, and then I output 76. Then I back up to 2. So this was now after the function call with 76. I get the sibling of 76, which is 39. 39 is not null, and now I call depth first search post order with 39. I get the child of 39, which is 11. 11 is not null. Then get the first child of 11, which is null. I skip the loop and I output 11. So at this point I outputted already 76 and 11. Now I back up from the function call of 11, get the next sibling of 11, which is null. So I stop this. And this was the child of 39. So the node was 39 and the child that I passed in 11. So 11 doesn't have a next sibling. So then I output the node value 39. I back up to the node of 2. So that was a function call with 2. It had a child 76 and 39. When I go from 39 to the next sibling, this is null. I stop this and then I output 2. And then I back up to the function call of 7. So the node is 7. I called 2, which is the first child, and then get the next sibling, which is 13. 13 is not null. I call depth first search post order with 13. Then 13, first child is null. I skip it and I output 13. So this is essentially you have to trace down the recursive function calls to keep track of the stack. But this is exactly what it does. It does the function call all the way to 76. You can see it goes down to the children and all the siblings until there are no more children essentially, and then it outputs the value. That's why we go down all the way to 76, we output it, then to the children and all the way down to a leaf node, which is 11. And as we back up at the end of the function, after we visited all the children, we output the value. That's why 39 gets outputted after we visited the children. 2 gets outputted after we visited the children, and so on. I hope you enjoyed this video. Thank you for watching.